So when you see these two pictures, what is the first thing that comes in your mind? Definitely electric shock, current and electricity. So in this lesson I'm going to discuss about the electric circuit. So before going into the lesson, so let me present you some of the objectives of the lesson. So the first objective of the lesson is I'm going to describe about the electric circuit and its type, and I will be helping you to identify the electrical components and their symbols. And finally, I'll be discussing about which type of circuit is better for our household wiring. So firstly, let me discuss about the electric circuit or circuits. So the circuit are the closed path for electricity to flow through. So it is the closed path where the electricity can flow through it. So all the electrical appliances at home are connected to a battery or a main supply with the help of wires to form a complete circuit. So we have so many appliances at our homes like refrigerator, television, rice cooker, curry cooker, bulb, fan and so on. So all those appliances are connected with the help of wire, which forms a complete circuit, and it is helping us to function or use our appliances. So if the circuit is not complete, we won't be able to use our refrigerator, or we won't be able to use our fan or bulb. So in order to use our electrical appliances, the circuit has to be complete, and that circuit has to be completed with the help of wires. So basically we have two types of electric circuits. First one is a series circuit and second one is a parallel circuit. So firstly let us discuss about the series circuit. So before discussing about the series circuit, let me discuss about the two terms that is used in the circuits. So first term is the current and the second term is the voltage. So when we say current is a flow of charge, or the flow of charge is called as current or electric current, and the force which produces the flow of charge or current is called as voltage. And this current and voltage is very important in the circuit. So let us look into the circuit. The first type of circuit, that is series. So in series circuit, we have the electrical appliances connected one after another in series like this. An example is given here. So these three bulbs are connected one after another in series. So this type of connection or circuit is called as series circuit. So in this series circuit, what happens is the equal amount of current flow through all the electrical appliances. So when the current is flowing through these wires, the current will be flowing equally through all the electrical appliances. But the voltage or the force is distributed among all the appliances. So we have three appliances out here, and the voltage or the force that help the current to flow will be distributed among these three. So in this series circuit, if one arm of the circuit or if an appliance is removed or damaged, the circuit becomes incomplete and the electric current will not flow through the circuit. So if this fast bulb happen to fuse or happen to damage in the circuit, so the other bulbs will also not glow, or other appliances will not be able to glow. So secondly, the parallel circuits. In parallel circuit, the electrical appliances are connected parallel to one another, like this. So they are connected parallel to one another. So they are not connected in series. They are connected parallel to each other. So in parallel circuit, there will be equal amount of voltage flowing through the electrical appliances. So if you connect the appliances in parallel circuit, so all the appliances are going to receive the equal amount of voltage, or it is going to receive the equal amount of force that allow or that produces the flow of charge in the circuit. So, and the current will be distributed among the electrical appliances, which means the current which is flowing in the circuit will be distributed among the appliances. If one arm of circuit or an appliance is removed from the circuit, the other appliances will still continue to function. So which means if you remove one of the bulb out here, so the other will still glow, or it will continue to function. So if this fuse, or if it is damaged, so the other bulb will still glow. So that is the advantage of using parallel circuit. So the question is, which setup or which circuit is better for our household wiring, and why? So definitely the parallel circuit is better for our household wiring. The reason is already stated. So if I state it once more, if we use the parallel circuit for our household wiring, so it has greater advantage, because so all the appliances are going to receive the equal amount of voltage, and if any appliances is damaged or removed, the other appliances are still going to function. So these are the 2 points or 2 reasons for selecting parallel circuit as a better electrical circuit for household wiring. So with the help of a simulation, let us try to check which type of circuit is better for our household wiring. Let us try to construct electrical circuit diagram, series circuit diagram, as well as parallel circuit diagram. So we have wires here, we have batteries here, we have bulb, and we have switches here. So I'm going to use this to construct the circuit. So I'm going to use 2 bulbs for series circuit and 2 bulbs for parallel circuit. So I'm going to construct the series circuit here and parallel circuit here, and I'm going to see which one is better, and I'm going to check out the 2 points that I had mentioned earlier. So I'm going to use 2 bulbs, 2 batteries for both the circuit. So finally I have constructed two electrical circuit out here. This one is the first one is series circuit and the second one is parallel circuit. So in the first series circuit we have used two bulbs in series connection. They are connected series to one another, and in the second setup we have used two bulbs that is parallel to each other. So I have used one switch here, I have used one switch here, I have used two batteries in each setup, and let us try to see the difference between the two setup. I am switching on the first setup and I am switching on the second setup. So in the first setup the rate of flow of charge is a bit slow because the voltage is being distributed in two bulbs when they are connected to series connection, and the brightness of the bulb is also not that bright. And in the second setup the rate of flow of charge is also a bit faster because the voltage is not distributed. Voltage is equally distributed among the two bulbs, and the brightness is also much brighter than the first setup. So this is the first point why we are using the parallel circuit for the household wiring. Because in parallel circuit we will have brighter lights or more powers in the light. In series circuit, as we see here, the bulbs glow dimmer. Now let us check the second point. Second point is if any bulb or the appliances is removed or damaged in series circuit, the other circuit will be also incomplete, which means the other appliances are not going to work. So let us check that. I'm about to remove this bulb. So I'm removing this bulb. So when I remove this bulb, the other bulb has also stopped glowing. So if I connect it again both the bulb starts glowing, which means if we remove one appliances or one bulb, the other is not going to work. Or if this bulb fuses or diffuses or damages, the other bulb is not going to work. So let us look into the parallel circuit. Let us try to remove one of the bulbs from here and check what happens to the other bulb. I'm trying to remove the second bulb here. So I'm removing it. So when I remove the one bulb, the other bulb still glows, or the other appliances will still be functioning or working as it is. So if I connect it again, so these appliances will be still working. So this is the advantage of using the parallel circuit over series circuit. So finally we have done with the simulation. Now let us look into the electrical components and their symbols. So these are the electrical components. I have mentioned a few out here and their symbols here. So this is a cell and it is represented by this symbol. And if we have more than one cell, it is called as battery, and the battery is represented with this symbol, 2 cells or 3 cells together. And for the bulb we have this symbol, and for the wires or conducting wires we have these lines, and for the switches we have different type of switches here. For the switches we use this symbol. For the voltmeter we use V, this symbol here with letter V in the center, and for ammeter we use this symbol with letter A in between. So with the help of the symbol we can construct a very neat and clean diagram. So if we are using the batteries and real pictures instead of this symbol, if we use the picture of switch and picture of bulb and picture of safe, the diagram may look messy. So if we use the symbols, it will be very easy for us to read the diagram, as well as it will look very neat and clean. So I have represented the series circuit diagram out here. Two bulbs connected series to each other with one switch here and a cell here, and this is the parallel circuit diagram. I have one cell here and a switch here and two bulbs connected parallel to each other. So this is how we use symbols to represent the components. So that's all for today, and if you have yet not subscribed to my channel, so please do so that you can receive the updates in my channel. Thank you.